Okay, so here we go. Velocity extra practice worksheet. Please attempt each problem first and then check your answers. If you just watch me going blah, 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 and going through this, it'll make sense, but when you get to the quiz, you will totally flop. So, attempt it first. Your brain needs to try. All right, 2 hours, 15 minutes. We're starting off with some conversion factors for time so that you recognize how to convert this, okay? So 2 hours, 15 minutes. We're dealing with hours and minutes, so this is 2.25 hours because 15 minutes is 0.25 of an hour, okay? 1 hour, 30 minutes. 30 minutes is 0.50 of an hour, so we have a 1.50, 1 hour, 30 minutes. 45 minutes, okay, that's 0.75 of an hour, 3/4 of an hour, okay? Those minutes are not going to convert into seconds because that's a lot. That's a large amount of time. 2 minutes, 30 seconds. Few minutes with seconds. So 60 plus 60, 60 for each second, 60 seconds for each of those minutes, plus 30 more, gives me 150 seconds. Okay? Oh, sorry, don't forget your units of measure. Bad teacher. Okay. 3 minutes, 45 seconds, so 60 times 3, 60 seconds for every minute. All right, that gives us 180 plus 45 more. 225 seconds, okay? 1 minute, which is 60 plus 20 more seconds, gives us a total of 80 seconds, okay? 3 hours, 20 minutes. So 3 hours, 20 minutes is a 0.333 repeating, so that's 3.333 repeating. With significant figures, do not let this limit your significant figures, okay? So make sure you do as many threes as you need to based upon the problem you're working with. 1 hour, 15 minutes, 1.25. And 1 hour, 40 minutes, 1.66666666666 on forever. So again, put as many sixes as you need to and finish off with a 7 for rounding off. All right. So, problem number 1. Notice the format for this is a little different. I'm not providing you the setup for the problem-solving process, but I still expect you to do it, and I expect to see your work in the problem-solving process. So, we have a wolf chasing a rabbit 75.0 meters west to a bush, and then chases and then chase the rabbit another 23.9 meters before catching it. Okay? If the entire chase lasted 92 seconds, what was the average velocity of the chase? Okay. So we can assume with this one that this is also going to be going west because in the question it's asking for the velocity. Seconds is measuring time. Meters west, we're dealing with displacement. All right, and you're going to have to add those up. 75 plus 23.9 gives us a total of 98.9 meters west. Okay, velocity is our question. The formula, velocity is displacement divided by time. Okay, now we have velocity, we have time. Time is in seconds, distance is displacements in meters, so we're good for that. No conversion necessary in the time. Velocity is the question, so we don't need to rearrange the formula, so just plug in our values. The substitution, so the displacement gets becomes 98.9. And the substitution for time is 92. Excuse me. Okay, so 98.9 divided by 92. Calculator says 1.07391. Significant figures, that has 3, that has 3, that has 2. So just 2 significant figures for our final answer. The 1 and the 0, the 7. We'll round that 0 up, so we're going to get 1.1. Units of measure, this was meters, this was seconds, so our units of measure are meters per second. The velocity is the question, so we need direction west. Okay, number 2. We have a car traveled 75 kilometers per hour for 1 hour and 30 minutes. All right, kilometers per hour, that's dealing with well, just speed. Hours and minutes, we got time, but hopefully you recognize we got to convert that. 30 minutes is half an hour, so 1.50 hours. Okay? Question is asking for how far, which is distance. Our formula, speed, time, and distance. Speed is distance divided by time. Distance is the question, so we need to rearrange the formula to solve for the distance. Magic triangle. D is over T in the formula. I need D over T in the triangle and speed in the empty spot. Distance equals, cover the D with my pinky. Distance is my question. So D equals S and T are side by side, so put them side by side in the formula and plug in values. So we have 75 for the speed multiplied by 1.50 hours. 75 multiplied by 1.50. Calculator says 112. Calculator says 112.5. Significant figures, I have 2 here, I've got 3 there. 2 it is. So the 1 and the 1, the 2 does not round it up, so 110 kilometers. Okay, if you look at our units of measure we're dealing with here, okay, we have kilometers per hour and we've got hours. The hours cancel, so you end up with kilometers. And no direction because it's just distance. All right, number 3. Bicycles 1 hour and 45 minutes. Traveled 37.8 kilometers. What was the average velocity? So that time and that, oh, that's south. Okay, so we have a displacement. Hopefully recognize that time needs to be converted. 45 minutes is 0.75 of an hour. It's 1.75 hours. And 37.8 kilometers. Okay, so our velocity is displacement divided by time. All right, displacement over, sorry. This is what happens when you skip a step. Velocity is the question. So because velocity is the question, I do not need to rearrange the formula. No triangle needed. Plug in my values. Displacement is the 37.8 kilometers. The time is the 1.75 hours. 37.8 divided by 1.75. 21.6 is what the calculator says. Okay. We want 3 significant figures for our answers, so we don't need to change that. The calculator gave us correct sig figs. Units of measure are kilometers per hour. And it's velocity, so we need direction, so it's going south. There you go. 21.6 kilometers per hour south. Question number 4. 2.1 meters per second, 510 meters south. Question is asking for time, meters per second. It says here velocity. All right, 510 meters south, that's displacement. Okay, so the formula we are looking for, all right, velocity is displacement divided by time. Time is the question, so we do need to rearrange it. D over T in the formula. I need D over T in the triangle, V in the empty spot. So T equals D over V, so delta D over V. Plug in my values. Delta D is the 510 meters. Velocity is 2.1. So 510 divided by 2.1. Okay. Calculator says 242.85 0.571. Significant figures, I've got 2 here, I've got 2 there. So 2 significant figures, the 2 and the 4. The next 2 will not round that 4 up, so we get 240. All right. Meters per second divided by meters divided by meters per second, you end up with time of seconds. Time is the question. It's going to be seconds or hours. We're dealing with meters per second, so it's seconds. Okay. Question number 5. We have a 7.85 kilometers per hour, 15 minutes. And it's asking how far did she run. Okay, so this is dealing with the speed. This is time. Hopefully you recognize right away that we've got to convert that time. We're dealing with kilometers per hour, so we mean our time in hours. So that minutes is going to convert it to hours, 0.25 of an hour. Okay, and the question is asking how far, which is distance. Formula that has S, T, and D in it is speed is distance divided by time. Distance is my question, so I need to rearrange that. D over T in my formula. D needs to be over T in my triangle. S in the empty spot. So D is the question. S and T, cover it with your fingers. S and T side by side in the triangle, side by side in the formula. D is ST. So plug in the values. S, 7.85 multiplied by 0.25 of an hour. .85 multiplied by 0.25. Calculator says 1.9625. Significant figures. My original numbers, I've got 3 and I've got 2, so 2 significant figures. The 6 will round the 9 up. Okay, so 1.9625 rounded to 2 significant figures. The 6 rounds up to 9. The 9 will round up to 2, so it's going to be 2.0. 2 significant figures. 2.0. Distance, we're dealing with kilometers per hour. An hour, so it's kilometers. Okay. All right, we've got Bob, and he's walking his dog. He walks him north, and he walks him west, and he walks him east. And Bob's average speed, and it asks how long he was walking the dog. Okay? So 1.1 kilometers north, 2.6 kilometers west, 5, oh, that's supposed to be a 0.7. Ooh, photocopy bad. 5.7 kilometers east. Okay? But it says his speed. All right? So in the end, we're dealing with speed. It's not velocity, so the direction doesn't matter. So we're actually just going to add all those up, just like solving for distance. Because the speed, 0.96 kilometers per hour, is what we're dealing with. That's just speed, so direction doesn't matter. So I take that 1.1, add it to 2.6, add that to 5.7 for a total of 9.4 kilometers. Question is asking for how long he was walking. How long he was walking is not asking the distance, it's asking the time. Okay? How long does it take you to get to school? How long does it matter? It's a question of time. Formula, speed is distance divided by time. Time is the question, so we need to rearrange that. D over T, S the empty spot. So T equals, that's what I want to know. I end up with D over S. D over S. All right, so plug in your values. D, 9.4 kilometers. Over S, the speed of 0.96 kilometers per hour. So 9.4 divided by 0.96. It's 9.791. Okay, so that's the calculator says. 9.791666. Okay, significant figures. Go back to all your original numbers. I've got 2, 2, 2, 2, 2. So 2 significant figures for answer. We have the 9, the 7, and then the 9 is going to round that 7 up to an 8. So we get 9.8. And we're dealing with time. Our units of measure, we're talking about kilometers and kilometers per hour. So that must be time in hours. 9.8 hours. All right, so that's the front side. The back side has to do more with reading graphs. Okay, so speed graphs. So it says use the race results graph to answer the questions. Well, here's our graph for race results. All right. First, it asks who is the fastest. All right. So fastest has to do with the steepest slope. Okay, steepest slope. They're doing more distance in less time. So the steepest slope right over here, that solid line is going to be Marissa. Who is the slowest? Well, that's going to be one with the least slope. Okay, but the least slope, that's going to be this one over here. Lots of time to cover long distances. Okay, so you could say it as less time, less distance per time, or more time per distance, however you want to see it, but it's the same thing. So right there, that's Jenny. Jenny's the slowest. Okay? Who was 40 meters from the starting line at 5 seconds? All right, well, 5 seconds and 40 meters from the starting line. Starting line is going to be 0. So 40 meters from the starting line is going to be a distance of 40. A time of 5 seconds. Who was right there? Our little dotted line there, that's Rosa. Who never finished the race? Well, to finish a race, you have to cross the finish line. Well, if you look at this, finish line is a question of distance. This person got to 100, this person got to 80, this person got to 100, and that person got to 100. So these 3 people probably all got to the finish line, which is probably 100 meters away. All right? So, look at this. Da, 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 da. Boom, boom, boom. It was Rosa who never finished the race. She never got to the 100. Maybe she fell and sprained her ankle and gave up or something. Okay? How far did they race? Well, those 3 all went to the same distance of 100 meters, units of measure. All right, so question number 6. How much time did it take Kate to run the race? Kate. Kate's this one right there. How much time? So she ran the race. She got to the finish line of 100 meters in a time of 20 seconds. So how much time did it take Kate to run the race? 20 seconds. Using the data of the length of the race, right there, how far they race, 100 meters, and the time to run the race, calculate Kate's speed. Remember, speed, all right, is distance over time. So the distance she traveled was 100 meters. The time it took her to do it was 20 seconds. 100 divided by 20 gives us 5, and units of measure, meters per second. 5 meters per second was her speed. Now, something with graphs, we can assume that these are all perfect numbers, so significant figures are not so much of an issue. So don't worry about it too much. We'll just leave it at 5. Okay, next graph, traffic. Use the traffic graph to answer the question. So here's the graph on traffic. It asks which vehicle is the fastest. All right, so we're dealing with distance versus time graph. All right, looking at all of those graphs, fastest means the steepest slope. All right, which one has the steepest slope? Well, it's going to be that one right there, the solid line. That is the motorcycle. The motorcycle is going the fastest. Which vehicle's not moving? Not moving, well that's weird. Okay, so not moving means that as time passes, your position doesn't change, your distance. So a certain distance, and it's still in that same position, that's still the same, still the same, it's still the same, it's still the same, it's still the same. Always 20 meters from our 0 point. A horizontal line is a vehicle that's not moving. That's the car. Which vehicle has a medium speed? All right, well, if we say this is fast and this is not moving, then I would say this is probably slow, and I'd call that medium. So I'm going to say the SUV has a medium speed. Which two vehicles never cross paths? Well, cross paths means they're in the same place at the same time. Okay? So right here, we have the car, and we have the motorcycle. They cross paths right here. They're in the same place at the same time. Okay? Right here we have the car, and we have the SUV. At the very, very beginning, when time is 0, they're the same place. Okay? Here we have the truck and my car, the truck and the car. Okay? These two graphs right here, they never intersect, so they never cross paths. So we're dealing with the car and the truck. Okay? Do all the vehicles start in the same place when the stopwatch time is 0? So at time 0, all right, so when time is 0, that's the stopwatch at 0 seconds. The motorcycle is at a distance of 0. The car and the SUV are a distance of 20, and the truck is at a distance of 40. So all of those do not start at the same place. No. How much time does it take the SUV to move a distance of 80 meters? All right, so here's our SUV. It goes from 20 to 40 to 60 to 80 to 100, okay? So, but it's moving a distance of 80 meters, all right? It started at a position of 20. When it got to the 40, it only moved 20 meters. During the next second, it moved another 20 meters. During the next second, another 20, next second, another 20. So, it moved 20, 40, 60, 80 meters. So in its full time we have the graph, it only moved 80 meters. So how much time did it take to move those 80 meters? 20 seconds. Okay? So calculate the speed. Speed is distance divided by time. The distance of 80 meters, it took 20 seconds to do those 80 meters. 80 divided by 20 is 4 units of measure, meters per second. Okay, so that is the worksheet.